Hello, this is an intro to the Ownership at Large session. My name is Kinga.
And I'm Silvia.
We both software engineers at Facebook and we're part of the authors of the ownership management paper. Any organization owns a lot of assets. Ownership management is about finding accountable owners for these assets. This is very important as many pressing concerns such as integrity, privacy, reliability, and security depend on well-defined ownership. So that there is a clear responsibility when it comes to maintenance, code review, incident response, and so on. The term asset refers to any sort of entity that is part of a system in a company. Examples of assets could be source code files, or tables in a data warehouse, such as Hive tables, or it could even be software configurations. It's not enough to find an owner just once for these assets. The owners change over time due to company reorganizations, people leaving, changing teams, and so on. So this becomes an ownership health program, really. You don't just want an owner, you want the best possible owner at any given time, and this is where we propose our recommendation system. Basically, in an automatic way, proposes the most suitable owner. In that paper, we talk about an Ownesty-style recommendation system. Any company has lots of logs for different assets. We extract those logs and we turn them into features and features vectors. We also use these logs to create labeled data on assets and owners. We use this data to train our models. We then input all of the assets and feature vectors to make predictions. We then turn those predictions into explainable recommendations. Now, it is important for recommendations to be explainable as the owners need to understand why it's them that are the most suitable owner. In Ownesty, we do it in a systematic way. We have a meta-store that stores all the information about the assets, the features, and the corresponding recommendations. I've been mentioning the word feature a lot. Feature can be basically seen as an ownership signal. So for example, for files, it could be code or diff interactions. Diff is basically a comment at Facebook. It could also be file annotations. For different asset classes, such as data tables, it could be querying the tables down through dependencies or table creation signals. We gather all of those signals to then find the most suitable owner.
To train our ML model, we need some labeled data to use as ground truth. We have two main strategies to gather this ground truth for files. One is owner churn and the other is task resolution. So by owner churn, what we mean is when the annotation inside the file for the owner changes from, let's say, owner A to owner B. In this case, we will record a positive label for owner B and the given file and a negative label for owner A and the file. Similarly, if a task is automatically created for a bug present in a certain file, and let's say that the task is automatically assigned to Alice, Alice might decide that she's not a good fit for this file, she's not the owner, she doesn't know how to solve the problem, and so she might reassign the task to Bob because she thinks it's a better fit. Bob might then create a commit to solve the issue and close the task, and in this case we will assign a positive label for Bob and a negative label for Alice and the given file again. As you might imagine, building an ownership recommendation system like this isn't at all straightforward. There are a bunch of challenges that we encountered while trying to build this. Here you can see a brief summary. I will quickly go through all of them, and along the way I will also try and explain a bit of the design patterns that Ownesty provides to try and tackle these challenges. The first challenge that I want to talk about is the one of asset subclassing. We don't treat all assets of the same asset class in the same way. So one example might be Hive tables. Even though all Hive tables belong to the same asset class of Hive tables, we specify and define different subclasses so that we can apply different heuristics and different ML models based on the subclass the asset belongs to. One example of this is test tables. So We have identified this subclass of test tables where a test table has a prefix of test underscore and it's just the test version of another table. If we recognize that the table is in this subclass of test table, then we apply this very simple rule, which is whatever the owner of the original parent table, then we want the same owner to be applied to the test table. In the case of this specific subclass, the strategy we applied was quite trivial, but for many other cases we still need an ML model to assign ownership, and this strategy allows us to define where to apply each method. Another challenge is the one of team level ownership. So even though in most cases we want to surface a recommendation for the team level, most of the interaction that we get between owners and assets are at the employee level or individual level. So we need a way of systematically aggregating the employee level signal at the team level, and this is usually done by relying on team membership. One of the main problems we faced while building Honesty was the problem of ownership decay. In fact, while trying to gather ground truth, one thing that you need to take into consideration is that current owners are likely not a good source of ground truth. This is because hard-coded owners tend to get outdated after a while, and you need to consider how old the owner is when deciding if considering this as a label to train your model. Another thing you might want to take into consideration is how old a certain diff is. So, for example, an old diff might not have much relevance, and you might want to give more recent diffs more importance. With Honesty, we never want to have just one option when choosing an owner for an asset, so we try to have a set of owners or a set of owner candidates for each given asset. And what we want to do is to give a ranking of these owners, so to express a preference on which owner we think it's best. So our ML model performance is based on rank 1 accuracy, and we compare the performance against a random baseline where we randomly rank the owner that has some kind of signal for a given asset. But this design choice still allows us to recommend one and only one owner in a case where we might need to, and specifically in cases where we might have two on-calls that are very good match for a given asset, but we want to choose which one is the best one, or likewise in a case where we don't have any owner which is a perfect match, but we still need to find somebody that is good enough. So you might think of a case where we have a file which is very old, and for some reason we don't have any kind of signal for it, so we don't have any way of finding an owner. What we will do in that case is that we will look at the signal that comes from the folder level and the parent folder level. So from other files in the same folder, or from other folders and other files in the same parent folder. Similarly, in mobile, we might want to look at signal that comes from the back target or the package level. Back is simply a system that Facebook uses to build its mobile apps, so you might think of a back target in an equivalent way to a folder, basically. So again, by aggregating all the signal from the same folder the file is in, we might get reliable information who could be a good owner for the specific file. While training our model, we noticed a very interesting property that most of our features had. So most of our features were monotonic, so the stronger and the higher the feature value, the stronger the ownership signal was for a given asset and owner pair. This meant that we also changed all our features to have this property by design, so that we could embed this knowledge into the ML model, and this way we managed to avoid overfitting and have more accurate predictions. Finally, we're very proud to have explainable recommendations, so this allows owners to make informed decisions and when deciding if they want to reject or hopefully accept a given asset. The way that we do this is that in the case we're using a heuristic to make the recommendation, we will give a detailed description of what the heuristic is, and also properties and the values of the properties we used while making the decision. In the case of an ML model, we will provide all the features with their relative feature importance, together with their values and the main contributing features. We will also obviously provide the ranking of the top, let's say, 5 recommended owners for a given asset. Well, finally, I want to thank you, and if you're still interested in learning more, I would recommend checking out the paper for related work on ownership management and also the corresponding research challenges. We also invite you to check out the ICPC keynote for more coverage on the topic. Thanks again.